All right, then. I think we can go ahead and get started. So this is it. Congratulations, everybody. You made it to the very last session of Stir Trek. Woo! Oh, you sound so excited to be here, too. Welcome to Being a Good Evil Overlord, keeping your AI code-generating minion in line with TDD. As this talk title shows, I've been accused of many things. Brevity has not been one of them. Today we've gathered our league of no good, dirty, rotten evildoers to talk about how to keep our code-generating minion bots in line through an oldie but goodie test-driven development. All of my examples and code snippets today for the AI is with GitHub Copilot. And while a vast majority of my experience using these tools has been with Copilot, I believe that a lot of these techniques are generally applicable to whatever AI tool you're using, whether it's ChatGPT or Mistral or Bard or one of the other sort of like in-IDE generators. So hopefully this knowledge is something you can go back home and employ if you're using these generating tools yourself. So, you know, back when you go conquer Brazil or whatever it is you're going to do back there. So who am I? I am your overlord and master for this talk, Sean Wedig. Okay, yeah, it would actually be a lot cooler if I had a PhD, because I could be Dr. Wedig. It sounds a lot more ominous and befitting of a megalomaniac. But anyway, so I'm Sean Wedig. I am a principal software engineer at FISNA, not yet world ruler. But we're a startup, so FISNA then is a startup here in Columbus, actually. We're focused on 3D geometric search, which means we provide search capabilities when working with 3D models, CAD repositories, PLM systems, industrial automotive use cases, that sort of thing. There's a ton of interesting problems in this space with geometric algorithms, computer vision, and AI, which is a lot of what I do there. So FISNA is also the company behind Thangs.com. So if you're in the 3D printing space and you love to go spend countless hours tweaking your Bamboo Mini, you may have heard of Thangs. So anyway, it turns out we're all based here in Columbus. So what are we going to talk about today? It's pretty straightforward. So we've got the usual introductions and Q&A that make up the bread of a Tech Talk sandwich. And in the meat, it's deliciously evil. So we're going to talk about how these devious code-generating minions get out of line and generate all sorts of, call it interesting code. But before I can show you the solution to that disappointment in code generation, we'll take a short detour, and we'll talk about what I consider good TDD, and then how these minions make their interesting choices, and how actually TDD subverts the weaknesses in those choices so that we can subvert them to our will and get back to conquering the world. So, of course, then we'll have a nice Q&A, and, you know, like I said, like all good tech talk should have at the end. All right, so here we are. We are basically done with the introductions. Congratulations, you're 1/6 of it through, right? Because these are all definitely evenly spaced out throughout the whole talk, yes. You know me, you know the talk, you know the countries we're about to conquer. Let's take a closer look, then, at these unruly minions. What's the problem here? Because code generation always works perfectly, right? Of course. Okay, so I just want to get a sense real quick, at least for the people that are in this theater. Who regularly uses some kind of code generation tool, either through a chat interface or something in your IDE like Copilot? Maybe, actually maybe a little over half, 60% maybe, something like that, okay. Who uses Copilot specifically regularly? Almost a Venn diagram circle. For those of you using any code gen tool, how many of you have facepalmed so hard you left a welt because of what it generated? Also a Venn diagram circle? No, not quite. Okay, so I mean, clearly, we can get a lot done with these tools, but they are not perfect. That's like the understatement of the year. They're not perfect. And so at the end of the day, we have to remember that we are the masterminds, they are the minions. We're the ones in charge, we're the ones responsible to make sure the right things happen, the right code gets written, and that the right politicians get replaced by our automatons under our control. Because, you know, we're in charge. So if the minion's going to write buggy code because it doesn't understand the APIs, because it doesn't understand my requirements, because my prompt had a typo in it, I need something to keep it in line. I need to enforce that it's going to write the right code. Okay? Now, TDD has been, for decades at this point, a great tool for making sure that our code is correct, right? So if we have a bunch of buggy code already out there, we can write some tests, and that'll help catch our code. That'll help or catch the bugs. That'll help us enforce that we're doing the right thing, right? Of course. Yeah. And now, in these days of AI generating minions, or AI code generating minions, there's all these wonderful corporate demos that I'm sure everyone has seen where you just take a class that you've got some code for, you've written a bunch of code because you didn't have time to write the tests ahead of time. So you just feed it to this bot and you say, generate tests for me, and all your problems will be solved. They love that because then you can hide all the drudgery of writing tests. Okay, so let's walk through an example of doing exactly that. Here's my problem space, of course. I am getting ready to conquer the world. I've got my orbital laser cannon in geosynchronous orbit right now. I'm picking a target. Now, I need to show the world leaders that I mean business, so I need to find the right target. I've got myself a database of cities with X and Y coordinates. I know how to look them up by name. And so if I lay out a nice grid of the world here, horizontal is my X and vertical is my Y, I've got a satellite then that I can give positioning information to, and it'll target a city and blow it up. Or, well, turn it into white-hot, fiery plasma. So the other thing then is, in order to target that, I need to feed to my satellite the positioning in latitude and longitude. Okay, no problem. The code's pretty straightforward, right? Get coordinates, feed coordinates, positioning system, go. But something's wrong in my code. Something's wrong, and I can't just plug in Ottawa, and I'll hit the right thing. I've tried. So I need to get this back online. I need to get this auto-generated code working properly. So Canada, you're safe for now. I'm going to generate some tests, like we said. So the first thing, let's look at the code specifically that we are generating tests for. And of course, I didn't write my tests first. I've just got the implementation code on hand. I'm sure a lot of us are in that situation or have adopted code in this situation. It's already written, that's fine. So just to walk through this code, make sure everyone's online. So line 13 there is what I said. I was looking up in the database. I've got some city name, I'm passing in Ottawa. It gives me back the X and Y coordinates on that grid, okay? I take those coordinates, I feed them to my pew-pew targeting system. That positioning then figures out where we're just gonna send that white-hot fiery death. And then if it's positioned the satellite, if all the gyros and things do what it's supposed to, we go ahead and fire. Now it's buggy, it's not firing correct. And I've tried generating tests for this. So I actually went into the Copilot chat interface and I was just like, hey, write some Jest tests for this for me. I'm using TypeScript, Jest is a great choice, it's already there. Let's see some tests. And it kind of sketches out first, very verbosely, what exactly it's going to do, how to go about doing it, all the things you need to pay attention to. And it gives us, after a little massaging, some test code. It makes a test suite that passes, okay? And it looks perfectly sane. I'm sure you've seen this all the time. And in fact, it doesn't have any type errors. It actually transpiles appropriately. I can run it. It's not a problem. And even if you read it, these tests, this might be something you'd expect to see, right? The first one is, it gets coordinates with the correct city name. It calls the aim the pew-pew towards with the correct coordinates. It calls the initiate fiery death with the aim when the aim pew-pew towards returns true. All the things that you'd expect to see. But the specs that it wrote, what did it use to generate that code? Was it the requirements that I had in my head, the ideal version, or was it what was actually in my editor with the bug? And so sure enough, this test suite, which was supposed to catch my bugs, it returns true, it passes, it's great. It's just reinforcing the buggy behavior. Great, that's exactly what I wanted. So for what that bug was, by the way, for those of you that deal with, geosynchronous orbit targeting lasers, it's the arguments are flipped, right? That X and that Y do not map to latitude and longitude. So those arguments were backwards. Easy to mistake to make. When you're a world genius trying to conquer the world, you're busy. You've got things to do. You can't pay attention to swapping arguments. It's fine. So this is really my bug. So when I asked my Minion to go generate my test suite for me, it didn't know any better. It assumes that I'm doing the right thing, and so it will faithfully generate tests that back this thing up. Okay, another one. So say maybe I've previously been pretty good about this, and I was doing a good job writing my tests ahead of time. So I started writing tests for a bunch of situations. I've got this target and attack robot. It's my modular robot army, okay? It takes a weapon system and a targeting system and a movement system, okay? So that's things like a targeting system of LiDAR, and then it's got laser eyes, and it's on tank treads. Cool. So I want to make sure that in all of these situations, when I say target and attack, it can go do that. So I might start with a single test here. So I've got this cascade of contexts. So I'm dealing with the LiDAR targeting, it's bipedal movements, this one's walking around Terminator style, and it's got lasers. It's got frickin' lasers. My setup for this test has a bunch of fiddly configuration. It's just, there's a lot of OEM hardware on here. It requires me to put in this configuration for the movement system and for the targeting system and configuring the weapon. It's just, there's a lot of extra overhead in order to make this code function and not throw a bunch of errors at me. Okay, that's fine. So I'll just start my one test. I'll do all that stuff to get it out of the way, get my happy path, write my test. Great, I'm TDDing. Works out great. So then I might do another one. So then I'm working with missiles. And I still get the same problem. I've got this sort of like context set up that's kind of ugly. I got to do configuring of the movement and the targeting system and the weapon system. And yeah, most of that isn't actually important to my test because I'm just talking about missiles right now. But I need it there to make it happy. Okay, so I do that thing. Now I get to the third one. And the code generating minion will be very helpful here. It's like, oh, ho, you're talking about chainsaw hands, but you've talked about lasers and missiles before. I know what to do here. And it generates all this code for me. And it's so tempting to just hit tab, right? Look at all that code. You did one keystroke and you generated like 15 lines of code. That's awesome. You can rip through this test suite so fast. But what happens at the end then with all this fiddly configuration if I keep auto-completing like this over and over and over and over again? The next thing you know, you've got a test suite, and you probably can't read that eye chart there, but you've got a test suite that is like 75% repetitious setup. And your actual specs are completely lost in the sea of all your configuration. Because the thing you have to remember is that these LLMs, Copilot included, these large language models, they're just statistical likelihood engines. They just generate the next token. And it turns out, actually, we as humans that write our software code, we write pretty repetitious code. So when it sees us do something a couple of times, it thinks we probably want to do it a couple more times. So barring other guidance, the minion will keep generating that code. It'll keep duplicating it. But of course, we have to maintain this code in the next revision. We have to keep it going. And if we have all this code basically effectively cut and paste everywhere, what happens? Then you got a bunch of cut and paste areas that you have to go update next time. So we have to be in charge. We have to pay attention to what is being generated. We have to provide that same sort of feedback we would to a junior developer under code review. We have to look at it and decide that the test suite isn't due for a refactor. We need helpers, or we need something else like that. So yeah, this TDD is helping. It's making sure that my implementation code is good, but this approach clearly isn't working, and we're just going to incur a bunch of overhead down the line. So if we're generating tests, they've got to be good tests. But what does that even mean? What is a good test suite? Okay, for me, I think a good test suite of unit tests are tests that are spec-based, legible, maintainable, support fast feedback, and they drive your development. There's probably a few people that are immediately going like, yeah, it's just like your opinion, man. That's fine. I mean, okay, so this is such a well-traveled topic, test-driven development. I originally put millions. I'm actually thinking there might be hundreds of millions of blog posts, tweets, tech talks, whatever for what makes good tests and good suites and how to apply TDD appropriately for your team. But I'll bet none of those people have an orbital death ray parked in geosynchronous orbit, so you should listen to me, actually. As a side note, I will never grow tired of putting googly eyes on my slides. Okay, so there are plenty of ways to give full-length talks on just this topic of good TDD practice. And I've given a few myself in the past, but today we're really focusing on how this applies when we're dealing with code generation. So I'll be a little quick on this. If you're interested in geeking out on this later, come find me. I'd love to. Just save the flame wars because, otherwise, orbital laser. Okay, so my experience, though, this approach that I'm talking about actually will help you keep the generating minion in line. We'll talk about more specifically what that looks like a bit later, but for now, let me unpack what each of these bullets kind of mean. Okay, so first, spec-based versus just a test, quote unquote. A specification, defines what your software does. It's reviewable by almost any layperson to understand how the thing should operate. Versus a test is a more general term. It's just something that exercises your code. Right? You have integration tests, you've got end-to-end tests. They exercise your code in some way, but they aren't necessarily a specification. Now, a lot of what I consider this test-only thinking is a lot of times at unit test level when I see someone not specifying the behavior they're looking for. And you see a lot of things like we saw in that auto-generated code. It passes the correct parameters. What does correct mean? I don't know. That's not a specification. I can't understand what my code is supposed to do if I read that text string, because it just says the correct parameters. Is correct that it says peachy keen? Is correct that it passes the latitude and longitude in the right order? That's for us to specify. Okay, so that's still kind of a vague mention, right? Like, how do you know that you're writing spec-based thinking or using spec-based thinking when you're writing your tests? Now, if you're, I think actually what's really great about this is if you're using something like Jest, Jasmine, or RSpec, which is kind of where a lot of my test upbringing was, so sorry, that's what I'm going to lean on. I find actually the verbose mode really helpful. So when you run your spec suite, it'll actually write everything out, and it'll say with all the descriptions what the specs are. So you won't have to focus on your code, you can just focus on the natural language description of things. And if you can read that, and you could go implement the class, or implement the function, you've got a spec. So I suggest if you've got that kind of presentation for NUnit or JUnit or whatever, if you've got your test runner tools, take advantage of them. It actually really helps a lot for you to think about your tests this way. Okay, so for example, this is one of those that I think is actually pretty good. Of course, I wrote it, so, toot my own horn. But you can see here, like just reading this, if you're looking at this suite, you have a pretty good idea without seeing any of my code what's supposed to happen, right? So when I've got LiDAR and bipedal movement and lasers, it's finding the target with the LiDAR, it's locking onto the target with the laser, and then it fires at an 80% strength blast. Okay, like that's pretty easy to read. Now, once we get to the code, that might be a different story, but understanding what it's supposed to do is pretty easy. Let's see. In these situations here, it's easy to read, but it also is clarifying the specific arguments. That 80% blast, that full speed for the chainsaw hands, all those sorts of things are called out actually in that description. So it's no longer correct parameters, it's a specific number. It's a specific value. Now this is opposed to a lot of how I see a lot of engineers writing specs with the it does the correct thing. Where it's something like this. We've got the same nested series of contexts, the same movement and targeting and weapon systems, but all we're saying is finds and attacks with the correct parameters. How many people have a test suite that looks an awful lot like that? Yeah? Okay, actually, good. I'm glad that's not many. I've run into plenty of that. This is arguably better than no specs, but I think we can do a lot better. So again, that natural language over on the, let's see, that's the left side. You don't even have to know the code. You can just read it and understand what it's supposed to do, and it's not just a test. There's plenty of reading online about that. So let's talk then, so once we have our spec-based suite, we need it to be legible. That was the second point. Now, it turns out that legibility is great in your implementation code. Everyone will agree that that's an important thing to do. It's great for your specs as well. And while there's tons of craftsmanship in writing, or craftsmanship in documentation, and ways to approach writing really legible code, and so you'll get 10 million opinions when you ask 5 million people. I think actually within specs, within test suites, especially something like RSpec or Jest, there's actually some really simple litmus tests in order to make this work. So here's a couple guidelines. The high level is, if you want your code to be legible, you can think of it in a different way. Instead of saying that kind of vague term, you can say, my spec suite can be tested by inspection. Okay, that term, tested by inspection. I wish I could credit it. I don't know where that came from. Basically, what that means is that your code for your specs need to be simple enough that if I read the description and then I look at the code, without running it, I know it's right. Sounds challenging, right? It's a little bit easier than you might think. So what are some ways that we can make our specs testable by inspection? Well, again, for something like Jest here, we can use describe blocks for nested contexts. So every time when you write your spec, right, you have to arrange whatever the context is, what the targeting parameters are, the configuration of your robot, whatever that thing is, before you act, you run the function that you're trying to test, and then you assert. Arrange, act, assert. Describe blocks, if you move all your arrangement up to that, then you have a self-documenting approach. You have that text where I say, when there is not currently a detected intruder, then the immediate before each that goes right beside it shows how I'm implementing that there is not currently an intruder. That intruder count is 0. Really easy to follow, right? I've kept that context limited in scope, so that I read the text, I can see exactly how it's supposed to be implemented in my spec suite. If I need a more compound idea, because it's maybe that there are no intruders, but there's suspicious activity, I can nest another describe block. It's kind of like if you ever heard the yes and rule in improv. It's kind of the same idea here. You nest those describe blocks, so I can say, there's not currently an intruder, but I'm also seeing something a little sketchy, so I need to behave a little differently. There are all sorts of those things. We have all sorts of nuance and conditionals that we need to pay attention to. Nesting these contexts lets you separate and tease out all those concepts, so that then our specs themselves can actually follow suit, right? They also can be explicit and spec-based and limited in scope. So here, for these two examples, I've got, it's in it's in detection mode only. And the only thing I'm checking is what the laser grid's detection mode is right now. The bottom one, when it's in high alert mode, the natural language tells me exactly what I'm looking for, which is when I look at that mode, it says high alert. Very easy to read. Again, these are limited in context. They deal with one featurelet, one part of a feature, and the spec is explicit about what it's doing. So in this way, your specs, the tests themselves, actually stay very focused, and you need to put very little code in them. They're conceptually super light. So you could have concepts that are stacked one after another, and I see a lot of specs or test suites that are that way, but if you keep them light, it becomes very easy to follow, it becomes very legible. So each spec flows naturally from to the assertion, and at a glance, you know it's right. So conceptual cleanliness. Descriptors flow naturally into the code, either for setup or assertions, and those limited concepts help at each step. And that goes then, when you have those contexts and you have a series of tests that you need to do, you can actually split them all up individually, and it reads very naturally, no problem. So, oops. Okay, so maintainable. So spec-based legible suite needs to be maintainable. I have done this more times than I'd like to admit. So I hear a lot of engineers say something like, oh, it's just test code, as an excuse not to apply linting, not to organize the code to make things easy to follow, not adding helpers, refactoring the code in the test suite. And you know what happens when you do that? The code, the spec suite, becomes unmaintainable itself. And then everyone hates adding tests to it because they know it's going to be a big chore, and then it gets super ugly, and eventually something breaks, and you don't have time to fix it because you're going to need to ship by this Thursday, and then you end up with this huge pile of spaghetti code that ends up just getting skipped all the time, and then you have no test suite anymore. So your spec suite, your test suite, is part of your code base. You need to treat it that way. Treat it with the same care and dedication that you do your main production code, because it supports your main code base. It's something you got to live with day in and day out. In fact, if you're TDDing, you're probably living most of your time in that test suite. Why not treat it with a little TLC? So the other piece of this, though, is these code gen tools can help a lot, but because as we saw earlier, they just kind of get repetitious. They'll just follow whatever pattern. It's not really as good at refactoring or removing that repetition. We need to be the one to pay attention to that and identify that this is going to lead to unmaintainable code. So if you have that 1,000 line of repetitious noise, unfortunately, sometimes you might even want to send it to ChatGPT or to the Copilot chat, and you might want to be like, okay, I've made a mess, clean it up for me. If you've got 1,000 lines, it might not even fit in the context window. You might not even be able to send all of it there and have it rescue you. I've been there. So regardless of how you get to the fact that you need to do a refactor, you have to be the one to initiate it. You have to recognize that this code is no longer maintainable. So some ways to catch that, again, there's whole talks on this for looking for code smells. It's asking for things like, is it painful to set up a new context? Do I have a lot of fiddly stuff I need to set, like we were doing before? If I make a breaking change and it fails a spec, does it tell me? Do I know where it failed, or is it some vague error like panic? Great. Every time you add a new feature, you have to change the various before eaches in like 40 different places, yeah, you're probably overdue for a refactor. It's time to make that a little bit easier to work with. So maybe you could do something like use a builder pattern that only cares about the things that are specific for your test. So our specs are super important to understand how the system is meant to behave and how it does behave. So they need to be easy to change as well. Okay, so we've got a legible, maintainable, spec-based suite. It needs to support fast feedback. This one's really easy, so ironically enough, it's the fastest point. Your spec suite, the whole thing should be fast because you want to be able to run this all the time while you're editing, while you're making changes, so that it immediately tells you something went wrong. So you should be able to run that yarn test in watch mode and get feedback within 5 seconds, maybe 10 seconds of actually saving your file. That way, it's completely painless to just have it running all the time. And so when you get that minion generating code, and it generates something that's completely off the mark, hey, you find out right away. It tells you right away because Jess is going to scream that you just broke a test. So you need this spec to run really, really fast, most critically, though, because you need to be able to drive development on it. Okay, now, in my opinion, this is probably the most nuanced, most misinterpreted part of test-driven development. Maybe your experience has been different, but in mine, I see a lot of people misinterpreting what it really means to do TDD. So, a question. In the 3 words, test-driven development, which is the most important word? Now, a lot of engineers that I've come across will say test. That's the most novel thing of this, right? So as long as their pull request had tests in the end, we're doing TDD, right? Well, no. And to be fair, that was actually a trick question about the 3 words, the most important thing, because it highlights the misunderstanding. It's not test-driven development. It's test-driven development. Test-driven is a compound word, okay? And you may be thinking like, yeah, that's pedantic, word parsing in order to make a cheap point. You'd be right, it is. But for me, it was the most critical nuance in understanding TDD and making it work for me. The creation of the test, the creation of these specs is actually what drives the later development of your code. Your features emerge, morph, and change only under the guidance and purview of these tests that you're writing. And so if you want to add a new feature for error handling, it first materializes in your specs, where you say you expect it to fail, you expect it to swallow that error, you expect it to log it, whatever that is. That's going to fail at first, but then when you go back and you add that try-catch block in your implementation, that's when you make it go green. So that feature set evolves as you add the specs. Its tests are driving your code. That spec then puts all that pressure in order to implement something and implement it quickly. So if the only thing you note is that you have tests in your PR, and you only add tests after the fact, yeah, you get tests. And that actually is valuable by itself. There is value there. But you're missing out on what, in my opinion, is some of the biggest benefits of TDD. And that's this famous red-green refactor cycle. I'm sure a lot of people have heard of this, right? Red for failing the test first, green for making it pass, and then refactoring to put that critical mastermind level knowledge and oversight in order to keep things maintainable, right? So I find the best way to do this, actually, to keep it focused, to keep it effective, is one spec at a time. Before you write, and then when you have that spec there and it's failing for you, and failing in the way you expect it to fail, you write the barest, stupidest code possible to make it go green because you hate seeing those red X's. At least I do. You just worry about making that one test pass. So you can use that one spec at a time. You can expand whenever you expand or change functionality. As new specs get added and features change, you always get back to green as fast as you can before you add something new. You get back to that passing state as quickly as possible. To make this a little more concrete, take that modular death machine with like the 80 combinations there. Like it's got, a couple different varieties of targeting system and movement system and weapon system. So, if I'm setting aside the rather painful interface there to configure and operate this bot, we have a lot of tests for all these combinations. There's like 80 or something like that, okay? But if I'm writing one test in the context of a bot that has, olfactory targeting and boring old wheels and chainsaw hands, I can just make sure that it can find the target, applies enough torque to approach on the wheels, and spins up the chainsaw chain. I just focus on those things. In that way, I avoid overthinking all the different ways that this thing needs to operate. I only need to focus on one test. And so when I'm focusing, like I said, in order to make this test happy, do the dumbest thing you can. Make it green. Doesn't matter. Is it like verbose? Is it ugly? Is it code that you would not ever submit to your PR? It doesn't matter because you're not submitting to your PR. Just get it green. That fastest thing that worked, that naive implementation, gets you back to a state where now you can refactor. Now you can get clever. Now you can make sure that you still have working code because everything is glorious green check marks. And as long as, however you modify this code, it still stays all green, well, then you've got working code. And you can get as clever as you want. If you want to make that line noise like the bad old days of Perl, go ahead. It still works. So in this way, I find TDD is actually super, super freeing. It becomes almost playful. You want to see if you can do things in a single map call? Give it a shot. You think that there'd be a better variable name? Try it out. See if it works. You do that extra step, and if you do an extra step and you stage your changes before you go and refactor, if you don't like it, you just do a git checkout, and you're done. You're back in the green state. So TDD with this virtuous cycle lets us experiment with implementations, meaning you can make more legible code without fear of breaking anything. Okay, so we've got spec-based, maintainable, legible, suite running with fast feedback so that we can drive our development one spec at a time. What does this have to do with code generation? Like at all, right? You're probably like, okay, I was with you on TDD. What's going on here? Now, okay, beyond the obvious benefits here of having, making coding playful and joyful again to bring light and happiness to my bleak existence, it's actually really good prompting. Doing TDD in this way is actually a really good way to prompt the code generation bot. All of these code generators are simply generative AI systems, right? I think that we obviously knew that. They need prompted, just like ChatGPT, even though it kind of happens like magic. We don't really see the prompt. But if we peel back the curtain, we can get a good picture on how that works. So to really understand how this applies, we gotta go think like a minion. So let's dive in on how these code generation minions kind of operate, at least with Copilot. Okay, so we know some way to evaluate that good specs are good, or at least in Sean's particular definition of good. But how does that help us ask the bot to write code for us and write the right code? Well, ultimately, all we're doing when we get these fancy schmancy code completions from GitHub servers is we're prompting, okay? So doing that effectively, I think it's actually worth to step even further back and talk about prompting large language models in general. Okay, very quick. I'm going to assume, as a bunch of technologists living in 2024, you've all heard of large language models. Yes? Okay. And we have at least some exposure through like ChatGPT, Google Gemini, Bing Chat, Mistral, Bard, whatever your flavor of choice is. These systems are ultimately for generating text based on the statistical likelihood of the text that came before or after, right? It's a small chunk of text that they're trying to fill in. Ultimately, it's autocomplete on steroids. Things like ChatGPT are specifically tuned for a Q&A format, sure. It's better if you ask a question and it tells you something in response and back and forth, back and forth. Other models in this space, especially precursors, were trained on things like providing instruction on particular topics, where you give it a topic and it would generate an essay, or generating text in some other fashion. At the end of the day, it's just a statistical token generator. And okay, yeah, I am vastly oversimplifying this. There's a bunch of stuff that goes into the APIs that work for like Copilot, for like making sure that the code doesn't have obvious security blunders and that it doesn't obviously dump out copyrighted code and a bunch of things like that. It's useful to keep in mind, though, that under the hood, it's just what's likely to be the next line of code. So let's talk about Copilot specifically. Copilot comes straight from that line of LLMs. So originally, like the early version of Copilot was based on something that OpenAI put out called Codex, which was trained on, I think, it was like a fine-tuned version of GPT-2. These days, I think it's just GPT 3.5 Turbo. It's exactly the same thing that if you go into the chat interface. It's just got a couple layers on top to organize the prompt so that it gives you code. I actually don't know. This is actually about a year out of date when I found this information. But they're a little more cagey about what's exactly under the hood these days, probably because they're generating like $20 million a month in revenue on this thing, so they don't want to talk about how it works. So you know, that's one of it, or the things. So it's ultimately just an LLM generating the text for our code with some controls and wrappers to make it generate stuff specifically. But how does it actually think? How does our prompt get there? So we're going to talk about the life of completion. This is our code generation. This was also published about a year ago by the GitHub blog. The first part of this is we've got a series of contexts that it pulls together based on our editors, whatever we've been doing recently. It feeds it through some heuristics to get a prompt. It takes that prompt, it flies a couple of little extra filters to it, then it goes up to the GPT model, gives us completions. So in the case here, we've got that context, rolling back, is what tabs we have open, like what editor we're currently in, like where our cursor is, and it'll look at stuff before your cursor and after your cursor. And then it's got this vector database of other local code. It's got basically a way to look up other code to provide as part of the context. Feeds all that, again, through this black box of the prompt library, gives a prompt. That then has some additional filtering, which includes stuff like, what have you accepted recently? If you're working on a task, if you're working on that it returns a 404 not found, and you wrote that in your spec and that's a completion you used, it might think when you go back to the implementation that you probably want to do something with a 404 as well. So that's that contextual filter model where it'll apply a little bit of heuristic based on what you've been doing in your coding session. And then it goes up to GPT, it generates some completions, and it'll show some back to you. That's all you got to do. That's all it takes, you know, that little bit there. And I'm sure there's actually multiple parts beyond that too these days. But why does that work? Why does that help? Why does all this TDD stuff matter? Because as I said, that good testing, that good test practice is good prompting. So you saw about prompting, providing context matters. Oops. Okay, so yeah. So let's talk about prompting in general. A couple points on this one. If you've ever sent a wall of text to ChatGPT and you've seen that you've gotten noise and madness out of it, you're familiar with this first point. Small contexts and focused tasks are almost always better. There are fewer things to distract the system. If you explain what you're trying to do in different words multiple times, it's more likely to get through that thick robotic skull there, and it'll figure out what you actually want. Again, statistical likelihood. If you repeat it twice, it's probably going to stay in line. In that same vein, consistency pays off. If you provide a bunch of examples about how you want it to respond, and those examples are all structured the same way, it's likely you want the next response to be in the same structure too. But with all of this, no matter how you're working with these LLMs, you have to remember that you are the human here. You're in charge. You are the mastermind. Because with any generative system that human oversight is necessary. And you've seen all of the hilarious ways on the internet where it generates fake facts, it points at systems that don't exist, it cites papers that are nonsense, it pretends to be a Nazi, like whatever those things are, humans have to be involved. And so whatever it outputs, don't forget that you're responsible for that output. You gotta make sure it lives up to your standards. Okay. So really then, with what we talked about with testing and prompting, does it actually meet this? Does the prompting, or does the TDD approach actually make for good prompting? Spec-based. There's natural language interpretation right there, right before the code. We're literally saying the same thing multiple ways. We say it with natural language, and then we say it with our code. And so if there's more generation it needs to do, it can follow along that same way. It's less likely that you're going to write a spec that has a tag of responds with a 404 not found, and then have the body of it actually test that it's a 403 forbidden. So the minion can follow along just nicely. What about legible? Well, if a human can go read and follow it along, what were all these LLMs trained on? A bunch of text for humans. And so in that way, if you have your variables that imply what the functionality should be, it becomes very easy to expand out the code. Self-documenting functions and parameters indicate expected use, and thus what the expected follow-on code would be. And from that, the most likely content is something that probably aligns with what you're thinking. So once again, the same thing expressed in different words, in this case, variable and function names, provides a follow-on series of tokens. If it's maintainable, where we've made builders and we've simplified things, that also helps the LLM because we're shrinking that context. If you remember, if I throw a wall of text at ChatGPT, it might ignore a couple details, it might get confused, that sort of thing. Same goes in my spec suite. If I have a wall for every single context I want to set up, well, that's a lot for the LLM to pay attention to as well. Supporting fast feedback, this doesn't really help with the prompting, but what it does do is it helps you with the quality control piece of it. Because we know that it's going to make mistakes. It's going to generate something that's nonsense. It's going to not work right. So in that situation, I want to make sure that's the case. I want to make sure the code actually compiles. I want to make sure it operates the way I expect. And because I got a bunch of specs, I want to make sure it actually meets those specs. So, just to yell at me really fast if I mess that up. And then driving development. The LLM generates better responses when it has better context. So being focused, worrying about one thing at a time, will get better results. And as we saw when we were talking about how Copilot generates these, part of the context is your coding session so far. Like I said, if you wrote a spec about 404 not found, your implementation, the most likely thing is something about 404 not found because that's what your current coding session is all about. So by doing that sort of focused back and forth development, spec implementation, you're helping the system realize what your intentions are as you go. So like I said, that the context there, both of like what you have open, you probably have your test suite and your class under test open at the same time, how the context gets pulled. So, in my opinion, good TDD is good prompting for these code gen tools. That legible, maintainable, spec-based tests provide the extra context. The fast feedback keeps your quality control in place, and driving the development keeps it focused on the smaller tasks, leading to these better results. I'm going to zip through these kind of examples. Like if we apply this concept to some of the previous examples where things went wrong, I'm going to go a little quick through this. So let's say back to this orbital cannon code, right, where I was going to blow up Ottawa. Watch out, Canadians, here I come, right? When I first started, I just had a bunch of code written. I was asking it to generate tests for me, and it just reinforced my bug. So what if instead I back up and I said, I blow up my implementation, figuratively. I remove my implementation, and I start writing specs in first. And so here, then, I have the first couple lines written where I've got up top. The coordinates get pulled from the database. I get the position information. And those came after I wrote my specs down below, where I'm saying I retrieved the coordinates from the doomed city, where I attempt to aim the laser at the target with the targeting of latitude and longitude. Those specs get written, and then the completion that it's throwing up top kind of follows through. Now, because I'm trying to keep my code legible, trying to keep my spec legible, I might explicitly call out that this is latitude and longitude versus this X and Y, which might have called out the fact that aiming the pew-pew towards the latitude and longitude, I actually had my things in the wrong order. And because I'm going one test at a time, I'm actually gonna have my test suite here actually catch this problem. By focusing on just one little bit at a time and not trying to slam it all out at once and not trying to have the bot just generate it based on whatever I wrote, I'm going a little bit more hand in hand, and maybe, just maybe, I would catch this bug ahead of time. Okay, so the other example where we have the modular robot army with the 3 different types of modules. Instead of the massive amounts of duplication like I've got here, I recognize it needs some cleanup. And so before I'm really trying to even extend it even further, I go ahead and I create this builder. I'm just gonna zip through this, but the idea with the builder here is it's got sane defaults. And it's only when I call one of these like with targeting, with movement, whatever, where I override something I care about. And so as a result, the end object that I get out of this always has sane defaults populated. And so when I look at my specs, the only thing that matters is something specific to the spec. And so all of that noise with, with configuring each of the specific systems, with all the parameters and all the fiddliness, gets hidden because there are a bunch of sane defaults in this builder. My test gets simpler, I'm throwing less context at the bot, and so the next time that I generate another piece of code, it follows along. It sees that I've got this builder, it's gonna generate something a little bit more maintainable, ideally. So before we kind of wrap up, couple gotchas as you're invoking these bots. And you probably have inferred some of these or encountered these yourself. So watching your gotchas, your botchas. Anyway, we know that code generation loves repetition. It will not recognize the need for refactoring. It won't recognize the need for helpers, and it won't recognize the need for streamlining context. Even if when you go highlight a bunch of your code and say, refactor this for me, it might pick something completely different. It might make a refactoring that doesn't make sense because it doesn't have the context or it doesn't have the intelligence that you do. So it's gonna just repeat. It's just gonna spew out whatever is already there. So you have to be the pilot, you have to be the mastermind, you have to see all that and refactor it. If you've refactored and you made helpers, it's good about using them if they're there. The other thing with these code gen minions is they are loyal, loving minions that have perfect blind faith in everything that you do. It'll follow your lead, so if you write those bugs, it'll gladly reproduce those bugs. It'll write specs to enforce those bugs because you definitely know better. That goes double for the specs. It'll happily use your wrong assertions. Quick anecdote, I spoke at CodeMash this year, and I had a bunch of live code that I was working on, and I was showing how it could generate specs, and I was very excited, and then I looked at one of the generations, and I was making the point of, you have to be in charge, you have to pay attention to it. And it was just reproducing my wrong assertions earlier in my specs. And it only took someone else in the audience going, you're wrong there, for me to catch that. So they will happily follow along. The other thing then you've probably seen is, if you give them an inch, they will take a mile. They really, really want to help. They are so eager. They do not always know the right way to help. They're kind of like Gur from Invader Zim, if you ever watched that. If you don't have enough context, you have incomplete comments, insufficient self-documentation, whatever, it can generate a ton more code than you want, and it'll just be like, and just keep generating. So don't be afraid to reject those code completions. If you glance at it and it looks like madness, it probably is. Go ahead and skip it. So if you keep this in mind and keep the other stuff about TDD and how prompts work with Copilot in mind, maybe you can keep these minions in line. So we're here. We're at the end. Really quickly, what we talked about. We talked about the fact that code generation is great. It can easily run amok. We need to keep it under control. We talked about TDD and what I consider good TDD with spec-based, legible, maintainable, supporting fast feedback driving development that keeps your red-green refactor loop going. We talked about then how prompts work with LLMs and with Copilot specifically, and then the fact that we actually lined up that this practice of TDD makes for good prompting for code generation. And after all this, I hope all of you have a few more tools, richer understanding of the systems that lead to your code completions. Perhaps now you can bend these minions to your will the way that you hope so. So thank you everyone for coming and submitting yourself to my will for a little bit. I saw someone start a clap. If you want to see the slides, I'll share it in Discord and such, and send it to the Star Trek organizers. If you want to reach out to me, of course, I've got contact info up there. And otherwise, you can hit me up in Discord, LinkedIn, good old-fashioned email. Good luck with your robot army. I hope conquering the next continent goes really well, more smoothly than the last one. And here's to getting your death ray back online. I'm Sean. Thank you, everyone. Thanks, fellow villains.